Challenger Houston, we have good video. We're ready for your lesson. Go ahead, Christa.
Okay. Good morning. This is Christa McAuliffe, live from the Challenger.
We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
We've come a long way from the Wright brothers plane to the shuttle. We're planning on doing this.
Hi, my name is Ricky Arnold. I'm a classroom teacher and a NASA astronaut. I've always kind of wondered what was Christa going to do while she was up on orbit. And we're going to actually conduct some of Christa's lost lessons that were never had the opportunity to do because of the Challenger tragedy. Hi there, my name is Ricky Arnold, and I'm living and working on the International Space Station as a part of Expedition 55. Today we're experimenting with chromatography. Chromatography is a technique for the separation of a mixture into its individual components. Let's go ahead and get started. We have a mixture, this black spot, on a piece of chromatography paper. We want to see what different components of light make up black. So we're putting the water onto this end of the chromatography paper to see how the ink separates. Water is a universal solvent and should help separate the spots into colors. What do you think is going to happen? Talk about it with your classmates. All right, now let's see what happens. I'll go ahead and add some water. Here's the first one. The water is going ahead and creeping up the chromatography paper. You can already start to see not much separation here. Very little on this black one, but you can actually see the reds, greens, and yellows starting to separate and make their way up the chromatography paper. The substances, now in liquid form, travel over the solid, the paper, at different speeds, causing them to separate into the component parts. Now that we know what black ink separates into, let's think about how the water was able to move through the paper. I put a drop of water in just one spot, but as you can see, it moved along the paper on its own. How does it do that? Well, it happens through a process called capillary action. Capillary action is when a liquid like water moves upward due to its cohesive and adhesive properties. In other words, water molecules are able to essentially stick together and stick to one another, which is cohesion. And they can also stick to a surface or a container, in this case the paper, in a process called adhesion, and that adhesion pushes it upwards. This happens in microgravity and on Earth. You could try another experiment with chromatography with your parents or your teacher. Grind up some green leaves into a real fine pulp and use some acetone or nail polish remover instead of the water. Leaves are green because they have a chemical called chlorophyll in them, a chemical that can use sunlight to make sugar and oxygen through a process called photosynthesis. However, there are other chemicals in leaves that do the same job, but we just don't see them until fall when the chlorophyll breaks apart. Another way to see fall colors any time of year is to use chromatography. Well, now that we've done this experiment in microgravity, think about how this might look different on Earth. Will the material setup be the same? Will water behave in the same way? Will the same separations happen? Discuss it with a friend, then give it a try. Thanks for participating in our experiment today. I'm Ricky Arnold. We'll see you next time.